Large animals swim through water, and they also fly through air. Unlike the small swimming creatures that we just discussed, large flying and swimming animals operate in high Reynolds number regimes, where motion of fluids is dominated by inertia. One consequence of that is that flying and swimming of large animals are dependent in important ways on that characteristic of high Reynolds number, namely turbulence. Among other things, the dependence of flying and swimming on turbulence means that the popular conception of lift is largely erroneous. Lift depends not on flows of fluid over a wing, but on turbulent vortices shed by the wing. Here's where the similarity between swimming and flying comes to the fore, because thrust during swimming is produced in the same way that lift is produced in flying. As you watch the lectures to follow, I want you to keep a few things in mind. First, I want you to fully understand why flying and swimming are phenomena of high Reynolds numbers, and the crucial role of turbulence in the generation of lift and thrust. Second, how is it that turbulence can produce thrust against a surface, and how the physics of vortex generation shapes the locomotory behaviors of animals that both swim and fly. Third, I would like you to be thoroughly conversant with the Bernoulli model for lift production and why it cannot explain lift. And finally, I want you to be conversant with the principles of the Flettner rotor and the Magnus force, and how these two principles explain the generation of lift and what they say about the generation of vortices manipulating momentum in flowing air. And don't worry, you'll see what I mean by these terms.